All right. So, a couple little quick reminders and comments. Please, 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 please make sure you have signed into My Lab and have registered, even if it's with the 14-day pass. Make sure you have done that because I got the email today saying that I need to check or put in for my participation on Monday. And that's how I determine participation. So if you have not signed in to My Lab, and you didn't have to do anything, just literally sign in and get into the class. By the end of the day, it is a very good possibility when I submit the thing on Monday, you will be dropped. Because that's how I determine who's here and who's not. I have had, you're fine. Yeah, you're good. I have had this happen last semester, actually. I had 2 people dropped, and one person didn't realize they were dropped until the final exam. So do not let that happen to you. Make sure you sign in to the program. And I told them the exact same thing I'm telling you now. So that is how I check. Okay? I don't take attendance on a daily basis. I check online because that's where you have to do all your work anyway. For your projects, remember, I need an email before next Tuesday with what you're thinking about doing. I've gotten some really good ones. I've got a few people who have emailed me and it's like, we need to look at something different. So a quick, easy example. I want to know what the most popular purse is, or luxury purse is for women today. That's something we're going to be able to throw on a frequency table. Okay, it's qualitative data. You're not going to be able to really do anything with it. So the data you need to collect has to be quantitative. You have to be able to do calculations with it. Right? We're going to have to be able to do some population studies and things like that. So, like, if you want to do that, you can go, if we could find the data, look back and go, let's track the prices of luxury purses over the past 20 years. Have luxury purses got more expensive in the same brands, or have they gotten least or cheaper over that time? So it's like those type of things we can look at, because now we're looking at the prices and we're going to analyze those. Okay, so there's a way to do that. That's why if you're totally stuck, look at things that you enjoy doing, and we can go with that direction. And send me an email. Say, this is what I'm thinking about, but I'm not quite sure, and I'll send you back suggestions. All right, that's fine. I don't mind. What was the other thing with the projects? We won't have a ton of time in class to do it. However, most classes, I'm not going to be here after 5 o'clock. Typically, they're only going to last about an hour. So you have some time after class. If you want to get extra help or ask questions on things, you can do that right after class. And you do have that week in April that is basically my spring break to do your projects as well. So that's what that time was given to you for group work. You can email me. I'll be 5 hours ahead of you, but you can email me and I'll email you back. I'll have my computer and everything else with me, so that's not a problem during that week.
What week is that again? I'm sorry.
The week of April 13th, I think it is.
30th to 17th.
Yeah, because I'm leaving the 10th and coming back the 17th.
And also, My Lab is just on your website, correct? Like
No, the My Lab is where you do your homework, the stat.
on Pearson?
Yeah, Pearson.
Oh, okay.
That's the My Lab. So that's where you need to sign in. You don't need to sign in on my website. If you do, that's great. It'll help you track things on my website too. But you do have to make sure you sign into Pearson using the 14-day code. That's fine. Just make sure you were signed in so you can see all the assignments and that stuff's there. I will be creating the practice test for chapters 1 through 3 probably this weekend, and that will also be in Pearson in the My Lab, so you can use that to practice for your test. The test will not be online, but you can use it'll be the similar thing, similar type questions. All right. Any other questions that I have not answered? Good. All right. Forward and onward. Section 2.3 actually covered stem and leaf plots. I did that early, but that's fine. This covers another couple ways that we can look at graphing data. The first one is known as a frequency polygon. So a frequency polygon is a graph that uses points that are connected by line segments. The difference between this and the histograms that we were doing is this will use the midpoints of the graphs, not the class boundaries. So remember when we were looking at frequency tables, we were figuring out, or for class width on Tuesday, we were figuring out the midpoints, or that was one of the things that it was calculating. You just add the, or subtract, or sorry, add the two class boundaries and divide by 2. The lower limit, the upper limit, divide by 2. This is what a polygon looks like. So that is what a class polygon looks, or a polygonal graph looks like. So you've got your data. We have our class ranges. Here's the midpoints. And we calculate it. One of the things that is particular about the polygon is you need your beginning and your end. So the anchors, they're called, because they have to go back down to 0, are the midpoint for the class before and after. So if you look here, these are all basically going up by 3s. So you go down by 3 to get the other one, and up by 3 to get the last one. So that's how we get back to the 0. Right. And then these are just the frequency at those midpoints. It's just another way to visualize a histogram, basically. And since it is continuous data, the lines kind of have meaning. We're going to talk about that in a little bit for different types of graphs. You should be able to make these in StatCrunch as well. Let's see. Let me actually log into my lab and find out. Should be one of the graphs. Maybe not. Nope. StatCrunch does not have this type of graph on there. They have other ones, but not that one. No worries, I do. Any questions with the polygon tool? Or the polygon graph? All right. So it's just the midpoints. Go ahead. Do you want the definition of it? Hold on. This is what you want. This is what you want. That's the definition and how to get it. Stop flashing. All right. The next graph is very similar. It's ogive. Don't ask. I did not make up these names. An ogive graph is just a cumulative frequency. So it's done similar to what we did with the polygon graph. You're using the upper class boundaries, so we're not using the midpoints. And it's a cumulative frequency that we're attaching. So not the frequency in each one, so it's cumulative. It starts at 0 because obviously before the FERT begins, there is no cumulative frequency. And it can't go down because my frequency can never be negative, because that wouldn't make any sense. So a ogive graph always goes up. I'm in the middle of class, so what's the emergency? No, 4. I love you. Bye. Okay. Sorry, the water company's out in front of my house digging a hole, so I wasn't sure if there was actually something wrong. All right, so this type of graph is actually really useful when you're looking at being able to figure out like bottom 50%, top 50%, lower 25%, those type of things. So you can quickly look at the graph and determine that. I'll show you what it looks like in 1 minute. And you can do this with cumulative frequency or the relative frequency, which is just the percentages. Good? So you can see here, this is we'll do the exam scores. So here's an exam, like the list of exam scores. So here's my class limits. Notice we're talking about the upper boundaries. So the 55 is the boundary of the beginning one, so I start there at 0, and then I go up. So at 64, my frequency was 3. And then at 73, I had another 4 of those, so now my cumulative frequency is 7. At 82, I had another 5, so now my cumulative frequency is 12, and it just keeps going up. And the very last one should be your entire set. So it should be the total number of values. So in this case, I had 19 values, and that's my cumulative frequency there. All right, last type of graph. Time series plots. Actually, there's a bunch of other types of graphs, but these are the last one we're going to actually dig deeper into. So time series can be one of two things. These are always, so on the x-axis is always going to be time. And the y-axis will be whatever is what we're measuring. Okay, so these will always be time on the bottom. We're either looking for trends or cycles. So this type of data is going to look at what's happening over time. Okay. I have no control over that. It's annoying to me too. I don't know why. I would say it's my computer, but my screen's not flashing. So I don't know. So a good example of this would be climate change. It's a great example of this. Ever heard of the whole hockey stick thing for climate change? That's a time graph. It's looking at the temperatures over time, and all of a sudden they started going way up. You can look at it in terms of temperatures over the course of a year. So in January, they're going to start off pretty low, your high temperatures, and it's going to have that seasonal effect, which I will show you in a second. Okay. How much more you got? So here is a couple good ones. So here's a graph. So they have our data points there. This one's showing an upward trend. Here is the temperature one I was talking about, or in this terms, it's sales. So I'm going to go with they're selling something for the summer. Maybe ice cream. Peak in the summer. So you can see how the key is we can have years, months, days, it doesn't matter. As long as the x-axis is looking at time, you're good. Okay? It's just got to be time. And your y can be anything you're looking at in terms that translates over time. For some of you, depending on what projects and stuff you're looking at, this might be a good graph to look at. If you're looking at something that's happening over time, you can actually look at each year or day or month or whatever else based on that. So this might give you a good visualization of some of your data. Oh, wrong screen. All right. So what is the big thing that everybody keeps shouting online nowadays? Fake news and AI manipulation and everything else, right? That hasn't changed. Well, the AI is new, but the manipulation of pictures and information online has been happening forever, and even before online happened, it happened in newspapers. So a lot of times, this is where they use graphs to actually show and do some of that manipulation. So for example, here's a really great example. So the first type of graph that's actually can cause trouble is if we eliminate the bottom of a bar graph. And this happens a lot. Okay. So the first one, the one on the left, it looks like there's a big difference between those two bars. Yet it's only 0.1% difference between those two. So if I was to, so here's the thing, and I am, we're negotiating for our new contract, and we're negotiating with the unions about a percent increase in your wages. So you're going to get a raise. And I'm the union, and I'm fighting for 3.2%, and the state's fighting for 3.1%. Okay? If I'm sending out an email to everybody to show you this, or if I'm posting it online, I'm posting that graph. Okay? Why would I post that graph instead of the other one?
It seems like a bigger difference.
Right. I want you to sit there and fight for that 0.1%. Okay? I'm saying the state's screwing you. Look at all this extra money they're taking away from you. It's 0.1%. So in terms of $1, it's less than a penny difference. Okay? If I'm the state, I'm going, it's basically the same thing. So we'll give you 3.1, but we're going to give you this else. Okay? So why keep fighting over the 0.1% when it's basically the same thing and we're willing to give you this? Okay? So you can start to see how these types of graphs can manipulate your thinking. Now, was either one of them lying? Was either one of them showing you data that wasn't correct? Nope. All the data was correct. The numbers are there. The 3.1, the 2, all the numbers, even the numbers on the bars, were there. But what do we say about pictures? People look at pictures and see the colors and stuff like that. They don't necessarily look at the numbers. And that can be misleading and can cause you to think certain things. Way older than you guys. Well, some of you. There was a case of a woman in Florida who was pulled off of life support. Her name was Terry Schiavo. She was in a vegetative state for a while. And I don't remember if it was her family. One side of her family wanted to pull her off the feeding tube, and the other family side didn't, and ended up going to the state. And it became this big deal down in Florida. So they did a survey to determine the political parties and how they looked at this case. So here's the CNN USA Today poll. And it was based on what you've heard about the case. Do you agree with the court's decision to have the feeding tube removed, which in essence killed her? And this was the graph they showed. So what can you get from this graph? Just looking at the graph, forget the numbers, because I've already said that, so you're going to look at those. But forget the numbers and look at the graph. What implications would you get from this graph? Yeah. Yep. By a lot. Okay. When this case came up, this was another flashpoint for the pro-life versus pro-choice movement, things like that. And they were looking at, and Republicans typically are more pro-life, and Democrats are typically more pro-choice. So they were trying to frame this as, look, the Democrats just want to kill people. Same graph. But now it goes down to 0. You get a very different viewpoint. It was over 50% for everybody. By that point in the news cycle, everybody just basically, everybody felt for her at that point. She was in a coma for years. So, all right. But that's how politicians, media uses graphs to manipulate and show you things that might not necessarily be exactly what is true or what is the real situation. I didn't copy the rest of the graphs. It's fine. You get to see behind the scenes. Oh, that's what I wanted to do that one. All right. Here's another graph. What are some things you can tell me about it? Is it misleading? It might not be. I just literally grabbed it off the internet. So, yes.
I don't think it's listed.
Okay.
Just by looking at it, it just looks like it's showing. Like, I guess it skips around months. Rather than that, it shows like a very consistent.
It skips every other month.
Yeah. Still showing like a very consistent period of time.
Yep.
It's using like in the millions. It's using 1, 2, 3, 4 million.
Well, it starts off at 44 million, so it doesn't start off at 0. But if I start off at 0 and we're in the millions, is it really going to be so? And this is one of those ones that why I chose this one instead of some of the other ones I had looked at when I was quickly looking at them is that the other graph we were talking about starting at 0 can manipulate you. But in some situations, starting at 0 can have the other effect. It can. I knew there was something on here. Where is it? It can have this effect. I don't know where's this. So this is the effect that we're looking at. So if I had put all the way down to 0, it's going to compress all that information into one solid line, and you're really not going to be able to tell what's going on. Okay? So it's not always a bad thing to not start at 0. Because we always like talking about taxes. Good or bad graph? Not the content. Good graph. Starts at 0. Information's all there. Yeah, this is a good graph. Decent. Good or bad graph? Why?
There's way too much going on. You can't even see where the different graphs are, like where the different bars are, and it shouldn't be in 3D. It should be.
I don't know if they. To be fair, I haven't actually collected a whole bunch of graph like projects and stuff like that from my high school classes in a while. This used to be a very big thing. Like Word had put in the thing to be able to do 3-dimensional graphs, and everybody wanted to use them. But you're right. Way too much information. There's like 4 different things on there. It's like you really can't. The blue ones are behind the yellow ones, and the blue ones all look lower. It's like, yeah, you really can't figure out what's definitely going on in here. The information might all be completely accurate, but it definitely isn't a great graph in that respect. Another type of graph that's actually quite misleading is when they use pictures. So 100 to 200, 200 would double, right? So they did it. They doubled it. But they doubled everything. And since this isn't a geometry class, I'll tell you, when you double everything, you actually multiply it by 8, the volume. So if you take a box that holds a gallon of water, and you double all three sides, the height, the length, and the width, it will now hold 8 gallons of water, not 2 gallons of water. So when you're looking at those pictures, that 200 looks way bigger than the 100 or double the 100. So that can be used to manipulate you as well. I'm looking at, oh yeah, here's the, there's the climate change graph. What are some things you notice about this? First off, is it a misleading graph?
I would say so.
Okay. Why?
I mean, there's probably a way that they could somehow find the temperature, but in year 200, how would they accurately know the temperature?
Okay. That's actually what the gray bars are. That's what the gray is. Because they don't know exactly.
Like the thing that looks like sound.
Yeah. These are all individual measurements. So the black is the average. So these are calculated averages. But when they were doing, because exactly, they didn't have a thing to measure the temperature in 200 AD. But through trees and through ice samples and things like that, they can come up with some way to be able to figure out what the temperature was at that point. But it's not exact. That's what the gray bars are. So the gray bars, you'll notice, go up and down. Like that. It could have been as low as that, or it could have been as high as that at that point. I don't know. But what do you notice happening over here? Those gray bars are basically gone. Because now we have calculations to be able to find out the exact value. So that's one of the things they look at. It's like, okay, you don't know exactly what it was back then. For all I know, it was all the high points. Or it could have been all the low points. I don't know. It's somewhere in between those. That's what that black line represents, is the average of them, but not necessarily exactly what it was going to be. I can't read that one very well. I'm looking for a specific one. All right. Good graph or bad graph? Why? Very good. And what do we say about pie charts? Have to add up to 100%. So so now let's talk about how they actually asked this question. And they collected this data. How would they have gotten it to come up to be more than 100%?
It's probably out of 100 and something. It's probably a specific number.
Not necessarily. You could have said you backed more than one person. Then when they asked the question, they didn't say, which is your preferred candidate? They said, who do you back? I could have backed Palin and Huckabee. I didn't necessarily have to only back one. So when you look at those, that's kind of like what I did in class. I'm like asking you like what you were wearing. You're wearing gray and black. I would have put you in both categories. So it made it, the percentages won't work out that well because your total's different. So bad graph. Bad Google. Not what I was looking for. This will work. All right. So let's assume I left my pen in my classroom. Let's assume what type of graph is this, first of all? When it comes back up. A bar graph. It's actually a double bar graph because there's two bars on it. We're going to look at the tall ones. If I made this a point, these points, and I connected them, that was a horrible line of connection. Because everybody always likes to connect dots on a graph. Is this a valid graph? Ignore the bars, just the actual line with the points. Is that a valid graph? Why?
I don't know what it's representing.
Okay. So these are games that people play. Make up whichever game you want that starts with those letters.
Is it invalid because there's a line and there's no representation for the different points?
Yes. So a line has meaning. Okay? So when you draw a line between 2 points, the points on that line should mean something. So if I'm taking a bar graph and connecting them, what are the values between L and M? I have no clue. Okay? There's no games between there. These are individual games. So you can't necessarily connect them because that doesn't have meaning. All right? So when you're looking at a bar graph and you use points to represent them, which we can do, that is a totally valid way to represent it. You don't necessarily have to have a bar. You can put a point in the coordinates. You just cannot connect them. Okay? They have to be separated. So that is a bad graph. Good graph or bad graph? Yeah.
I would say no.
It says 70% more of kids under 18 play video games, and then it says 24% under 18. Like the data at the side, I don't understand compared
Is
to
the 24% the 24% of games are played by kids under 18?
I have no clue.
It's also 48 of video game players identified as female, even though it's only for this one age. Like, it doesn't have contribute at all to the graph at all.
Okay. Actually, I actually, now looking at it a little closer, I actually understand what the things are. So, out of the 4,000 people they surveyed, 24% of those under the age of 18 said they play games. But that's so these are out of the whole population. And thus, only the kids under 18, 71% of the kids play. So out of the kids who play games, looking at it two different ways, which, yes, would be a very bad thing because it makes it confusing. So, yes, that is actually not a very good way to look at it. There is another thing wrong with the game. And, yeah, they do have the 48% of video game players are female and everything else is about age. There is actually another issue with it. Because that actually wasn't what I caught on to. Look at the ages. What's wrong with them? Okay, so right there, so it says under 18, so we're going to assume that's fine. But yeah, you definitely would not necessarily want the same age there because they don't do that in the other ones, which is kind of nice. What else do you notice about the ages? Yeah.
The class width is different.
Yes.
Every single one.
Everyone is different. The first one is 18. The second one is 16. Then we have 19. Then we have 9. Everyone's different. And it's not even based on population because the population in each of those is not the same. So, of course, the category with only 9 years is going to be playing games less than the category with 19 years. So when they're looking at this a lot of times because that's typically the age ranges they use for demographic information, 18 to 34, 35 to 54, those are the breakdowns of it. And then they decided to do 65 plus because that's retirement age. But when you're looking at data, that could be very manipulative and misconstrued. There's one. Nope, that one's fine. I think this one. I swear I don't only pick on Fox News. I normally pick on the USA Today. Good or bad graph? Why? Yeah, it doesn't go from 0. And is it really changing by much? Yeah.
But it also says, it doesn't say for the year, it says under President Obama. So
Correct.
It wouldn't be 4 years.
I think this actually was in 2011, so it would. Yeah, he would have been in office 4 years at that point, or 3 years at that point. Yeah. Yeah.
Not only does it start at 0, but like it only does go to like 10%. So like when you're zooming in on this area, it makes it look so much higher
Yes.
than it is. Because not only is it not starting at 0, but it almost is reaching the top, even though the top is 10%, not 100%.
Correct. Although if we had 100% unemployment rate, that'd be very bad. Yes.
Yeah, towards that end, it's 9%, and then 8.6.
Oh yeah, I didn't even catch that one.
8.8 is lower than 8.6 looks like.
Yeah. Yeah, they didn't even go down at the end. They didn't even catch that one. Good catch. Oh, I like these graphs. Not necessarily a bad graph, but a nice graph. Not really. I want the whole graph. So these kind of graphs are kind of cool. They're not necessarily. It's not necessarily bad, but what's wrong with this graph? Yeah.
There's a lot of overlap. Like I can really make out Portugal because of being covered by Japan.
Okay. Okay.
I would say yeah, using some of these flags should be like just data flag just points.
Okay. So, what's the number one thing people look at in graphs? The pictures, right? And what do you always ignore? The data. Look at the actual data that this graph is looking at. Chocolate consumption, okay.
What's in Nobel?
Nobel laureates, people who've won a Nobel Prize.
Why are
Right. Is there any connection between chocolate and winning a Nobel Prize? Switzerland certain things up.
What is the R and P?
R is your it's basically how consistent the data is. So when we're looking at, actually, we get to that in chapter 4, which we do at the very end. You ever heard of the line of best fit? When you're looking at trying to draw a line from a scatter plot. So this is a scatter plot, and that will be the slope of the line that matches. So a higher R, the more linear the data is, the more of a correlation between the data there is. However, correlation does not equal causation. So Switzerland is like eat a lot of chocolate, you get a lot of Nobel laureates. But that's not the way it works. China's like, we need to eat more chocolate. And also notice the 0 isn't actually at 0. The 0 for this one's up here. It doesn't even start at 0. And I don't know why. What are they called? No. Oh, what's the name of it? Oh, I know I can use that one. I can't remember the name of this type of graph, but there's actually a name for this type of graph. Okay. Who won this election? I can't go on Facebook more than a day without seeing this graph. Actually, this one's from 2020. But I can't go without a day without seeing the one from 2024. Yeah, this is Biden. So, why do they show this graph? Correct. And then they look at it and go, look, there's a ton of more red than blue. Yeah, it's like, hold on, let's see if I can find the one from, was that the one from? No, this is the one from 2020. This is 2020s. So the blue population's almost identical to the red population in the United States. So there is, you go out to Wyoming and Montana and those things, you could drive for an hour or more and not see anybody. A couple hours, you can drive across Connecticut. And we got 3 million people here. An hour, like 30 minutes, you can drive across New York, and there's 10 million people that live there. There's 700,000 people that live in Wyoming. So, but these are how you can use graphs and data to manipulate things. And we can see why it works. The comeback to these is land doesn't vote, people do. So now show where the population is. And actually, let me see if I can find the graph. Yeah. You have to love technology today because we can make some really crazy looking graphs. Here's the United States based on population. You have Boston, New York, DC, Detroit, Chicago, Minneapolis, LA, San Francisco. You have your major cities. And then you have right everywhere else in between. So when you look at the population, it's drastically different. So that's why when you look at graphs, and the one thing I want you to get out of this lesson in particular is always look at these few things. The title of the graph, make sure it actually represents what it's talking about. The labels, they're labeled. They have actual units, and the units have meaning, unlike chocolate and Nobel laureates. The scale, it either starts at 0 or it's clearly continuous and there's a reason for it to be chopped. Like there is a reason. We showed one that starting at 44 million made sense. Like going down to 0 wouldn't have made any sense in that situation. And they have uniform increments that they go up by the exact same amount every time. And as with all media, where did it come from? Okay, what was the source? Where did the data come from that made that graph? Okay. Ask yourself those questions whenever you're looking at a graph. And in today's world with AI, anything can be made to look normal and realistic. So, as they say, do your research. Okay? Don't assume what you're being told is true. Look into it. What was a quote? It said, trust but verify. You can trust information, but verify that it's accurate. Especially before you share it. Tell your grandmother that too. All right. We're good for the day. If you have any questions, I'll stick around. We're done with chapter 2. We're going to chapter 3 next week.